We may have the biggest brains on the planet, but when it comes to senses, we can be seriously upstaged. Without landmarks, humans get lost. Yet beluga whales navigate hundreds of miles of floating ice. We need weather reports, but grasshoppers have inbuilt weather sensors. Raw nature reveals stories fit for science fiction in the strange world of animal senses. Just a few days ago, there were lush crops here. Then the plague came. These insects were once harmless grasshoppers, until a special sense turned them into a swarming menace. But what triggered this transformation? It began after 5 long years of drought. This grasshopper is on its own, looking for a quiet meal. The sensors it's using are typical for an insect. Multifaceted eyes spot plants at a distance. Feelers packed with receptors, touch, smell, and taste. There are also taste buds in its mouth, crammed into lips called palps. These are the final test as to whether it passes over a plant or decimates it. Predators are rife, so the grasshopper must be watchful. It's evolved 3 extra eyes to sense danger. 2 are hidden beneath the feelers, whilst the 3rd is between the multifaceted eyes. These special eyes detect movement and shadows cast by hunters. Grasshoppers don't normally like company, but starvation forces them together. It's now that their unique sense is activated. It's called the crowd sensor. The crowd sensor is made up of tiny hairs on the legs. When pushed for space, grasshoppers knock into their neighbors. The leg hairs are triggered. Then it's all change. Their color alters, their muscles expand. They begin a drastic transformation. Like an alien army on the march, this swarm mutates. Soon, they'll be able to fly. If crowding continues, the next generation will be monsters too. Instead of growing into gentle grasshoppers, the young develop into their menacing alter egos, locusts. The nymphs' bodies expand to a massive size. Their wings become clear and strong enough for flight. They take to the air en masse. swarms can engulf an area the size of Bermuda, devouring everything in their wake. A single desert locust can eat its own weight in a day. That doesn't seem much, but when 1 billion locusts get together, it's the biggest feeding frenzy on the planet. After a year of mayhem, the locusts die off, and the next generation returns to its docile form. Thankfully, grasshoppers don't mutate very often. It takes at least 5 years of abnormally warm, dry weather, followed by a shower, to trigger the change. Without the remarkable crowd sensor in a grasshopper's legs, this monstrous swarm could never take flight and survive the unpredictable climate. In extreme conditions, whether hot or cold, finely tuned sensors make the difference between life and death. A golden eagle tears at the flesh of a stag killed in a blizzard. But how did the raptor secure such a massive meal? It's all down to the bird's superior senses. It's spring and a great time for hunting. Cliff-top living has great advantages. It's a safe place to nest. There are good vantage points and updrafts to soar on. The eagle has its pick of lookout posts, and it spends many hours surveying the area below. Unlike humans, eagles have 2 points of focus at the back of the eye, so they can look to the front and the side at the same time. It scans the landscape in wide-angle mode. Once it spots something, its eyes zoom in. It can see 8 times more detail than we can. It stays up high until it's directly over the prey. Once locked on, it plummets to the earth at speeds of almost 150 kilometers per hour. Its target remains crystal clear since it can rapidly change focus as it descends. It's a scene that will be replayed many times. But not every hare that's spotted is quite so easy. In winter, the eagle's eyesight is just as good, but white hares are scarce and blend into the background. Our eagle is forced to look for other prey. In wind and snow, our eyesight would be severely impeded, but the eagle has evolved a special inner eyelid. This acts like a windscreen wiper, but because it's transparent, the eagle never misses a trick. These deer are more visible than the hare, but they are too big for an eagle and come heavily armed. harsh weather is taking its toll. An eagle's best chance now is not to spot a kill, but a casualty. The raptor's eyes are its lifeline, whether hunting or scavenging. Without the superior sense of sight, this giant meal would have been lost under the snow. Head north to the Arctic, and the pressures are greater still. The polar bear and the beluga whale share this icy domain. So how do they survive life well below zero? It's all down to their specialized senses. But these senses are totally different. They've evolved in two different worlds. The belugas live below the ice, the polar bear above it. Somewhere beneath this ice sheet is a pod of whales. To breathe, they must come to the surface. Along the ice edge and within the loose pack ice, wind and currents create cracks. So how do the whales find breathing holes in this constantly changing landscape? The answer is echolocation. They emit a series of high-pitched clicks. These bounce off objects and return to the beluga in the form of an echo. In this way, they create a sound map of the area. Belugas have small ears, but sound is sensed mainly through their lower jaw. Fat inside the jawbone conducts sound waves to the middle ear. The message is then passed on to the brain and interpreted. In this ice-cluttered sea, echolocation means the whales know where to come up for air. Without it, they drown. But the need for breathing holes makes them vulnerable. Polar bears don't have sonar. But they do have other extraordinary senses for finding food in this icy desert. Like the eagle, their eyesight is acute. There's a lot of glare from the ice, so they have a protective membrane over their eyes, a bit like a pair of ski goggles. But it's their sense of smell that's truly astonishing. They can sniff out food more than 30 kilometers away. This bear has picked up a scent and is following its nose to the source. A hole in the ice where whales and seals come up to breathe. It will wait by this window of opportunity for hours. Eventually, something will have to come up for air. In the depths of winter, breathing holes are few and far between. The beluga is desperate for air. The bear strikes, but the whale's too quick. It sensed the bear's vibrations at the last minute. A lucky escape. It rejoins its pod. They have just enough air left to find the next hole. Polar bears rarely catch belugas unless they're old or sick. But sooner or later, the hole will offer up another potential meal. Waiting in ambush is not always an option for the bear. Because even the Arctic has a summer, if only a brief one. As temperatures rise, the ice sheets break up. The bear must return to the mainland to find food. Briefly, it enters the beluga's world. But this predator's super sense of smell is useless in the water. It closes its nostrils as it dives. Underwater, it can hear the tantalizing sound of belugas, but hunting in open water is far too difficult. The great melt has freed the whales, and they begin their annual migration. They head south to feeding areas that have been icebound for months. At 1.5 tons, belugas are built for mammoth migrations. But the next animal weighs less than a peanut, yet it too makes an epic journey. These monarch butterflies begin their adventure high in the mountains of Mexico. Their destination is Canada, 4,000 kilometers away. That's 1,000 kilometers further than the belugas travel. But without a map to guide them, how do these fragile travelers know which way to go? A whole range of navigational skills must be important. But good memory can't be one of them, because no single butterfly makes the entire journey. It's a 3-generation relay race. 3 times along the way, the butterflies breed, die, and then let their offspring continue the journey. So, if we rule out memory, what about smell? It guides them to food, but probably isn't strong enough to navigate by. Stars are another navigational tool, but the monarchs rest at night, so that rules them out. On bright days, it's thought the butterflies use the sun to guide them. But what happens when it's cloudy? Might it use its head? The head contains magnetite crystals. Could these line up with the Earth's magnetic field like a compass? As yet, we don't have enough sense to prove the theory. What we do know is that come summertime, the butterflies arrive to breed on the shores of Lake Erie. But this new monarch generation has a twist. Its sense of direction is reversed. While its parents flew north, this swarm heads southwest. Even if they do have an internal compass, how does this new generation know to change course? The truth is, we just don't know. The feat of these delicate animals remains one of nature's most enduring mysteries. By comparison, this fly's senses appear to be rather simple. Otherwise, it wouldn't fall for a trick as basic as the Venus flytrap. Or would it? So is the fly as clueless as it seems? A fly's eyes are so large that there's little room for a brain to process information. Each is made up of hundreds of tiny eyes which work like miniature cameras, every one creating its own picture. The fly then pieces together all these images to form a mosaic-like vision of the world. It's thought that flies don't see movement, but a series of frozen images, rather like an old-fashioned movie. These compound eyes make the fly short-sighted, so their close vision is extremely powerful. A fly can see tiny details where we need a microscope. But the rest of the world is a blur. This fly can not only see what it's stepping in, but taste it too. Like many insects, they have taste receptors at the ends of their legs, on their snout, and on their wing cases. But while its feet tell it what to eat, they can also lead it into danger. The brightly colored glands on the inside of these leaves are designed to attract a short-sighted insect. It walks right into the trap. Its senses may be sharp, but this plant can outsmart them. Whilst the fly is covered in sense organs, this animal keeps its tricks up front. Smell is crucial to this bearded pig and his family. Food is well hidden in their Malaysian forest home. Without their big noses, they'd starve. But it's not just size that makes the snout an effective tool. The round disc of cartilage at the end is under fine muscle control. So a pig can search and sniff at the same time, and close up its nostrils to stop it getting a lung full of mud. The family has sniffed out all the food in this area. Now they must move on. In a year, they follow their noses across hundreds of kilometers of forested valleys. Without that sense of smell, family members could easily get lost. Each pig in the group has a signature scent, so leaders and followers can fall in line. Scents are also used to advertise emotions, define relationships, and reinforce family bonds. All important when stops are often brief. Some plants exploit this by mimicking the aroma of pig sex hormones. The plant benefits because its seeds get more widely dispersed, and the pig enjoys a hearty meal. While the snout picks up smells, the whiskery beard detects grubs and insects. But it's no time before they're on the move again. Next stop for the pigs is under a macaque troop. Instead of digging for their dinner, the pigs simply vacuum up the fruit that the monkeys have dropped. Pigs can and will eat almost anything. With everything invested in that snout, their eyesight has suffered. While other animals look out for potential threats, pigs probably have such poor eyesight that they can't even focus. So putting all your energy into a super snout can have its downside. Piggy eyes don't see trouble coming until it's far too late. These peccaries may be on the other side of the world from our boar, but they're just as smelly, and their pungent odor acts as a calling card to a major predator. The massive feline pulls back its lips to draw in the scent. It tracks the odor until it's close enough to spy its quarry. Each of the big cat's eyes has a highly reflective layer at the back. This layer throws light onto the retina, perfect if you live in dimly lit forest. Hunting on dry land isn't always an option for the jaguar. In a few weeks' time, this habitat will be unrecognizable. While the annual rainfall in most of the world is measured in centimeters, the Amazon has many meters of rain falling each year. For 6 months of the year, the trees are surrounded by water and fish swim through their tangled roots. If a jaguar wants to find food here, it must get its feet wet. It's a strong swimmer. But the water poses a problem. A turtle makes a perfect meal, but first, the cat has to find it. It can't see well underwater, so it feels for prey using its whiskers and paws. A massive head and stout canine teeth are ideal for cracking open this well-armored reptile. But it has no hope of catching faster prey in these murky depths. There's one mammal, however, that has truly mastered this underwater world. The giant otter. This animal's amazing senses make it equally at home in water and on dry land. Highly social, the otters live in small family groups of up to 9. They play, sunbathe, groom and hunt together. Their incessant chatter resonates through the jungle. Local people call these otters river wolves because they hunt in packs. Perfectly adapted for the murky river water, their streamlined bodies and paddle-like feet make them efficient and graceful swimmers. The otter's eyes and nostrils are high on its head. It can see and breathe even when the rest of the body is submerged. As soon as the head goes underwater, their nostrils close, like the polar bears. A special valve protects the ears against water pressure. This means they must rely almost entirely on vision. Fortunately, because they can change the shape of their eyeball, they can see as clearly under the water as they do at the surface. It's not a perfect solution. When the water's dirty, an animal would need X-ray vision to avoid obstacles and find food. Giant otters have the next best thing. These long, sensitive whiskers pick up the regular vibrations caused by fishes' tails as they swim away. The combination of touch and sight proves lethal. When killing a deadly piranha comes this easily, you know you're watching one of nature's most efficient hunters. The giant otter can adjust the shape of its eyes to cope with hunting in water. But the kingfisher has a different solution. Like the golden eagle, it has 2 points of focus, but instead of seeing forward and sideways, this little fisherman adjusts his eyes to see above and below water. It's the equivalent of a spear hunter putting on a mask. The kingfisher has 2 eyes in one. But there's another problem all anglers face. Light bends when it hits water. The distortion plays tricks on the eyes. An attacker must allow for this, or it will go hungry. So, instead of aiming straight on, the kingfisher aims for a spot slightly to the side of where the fish appears to be. An adult rarely misses. But it's not instinctive behaviour. Young kingfishers must learn how to make the adjustment. If they don't catch on, they'll quickly starve. Some fish can outsmart the kingfisher. All fish have a lateral line that senses water movement. For these tetra, it's a lifesaver. When they feel the water move on one side of their body, a reflex makes them jerk in the opposite direction. Bad news for the kingfisher. Whilst it's difficult to hunt from air to water, it's no easier to hunt from water to air. In the rivers of Indonesia, these archerfish are stalking food in an unexpected place. A fly cleaning its wings is looking out for threats from the side or above. But the real danger is below. Unlike most fish, an archerfish's eyes face forward. This gives them binocular vision, similar to our own, so they can judge distance and direction. A perfectly aimed jet of water, and the fly's knocked from its perch. It may take several shots to floor the fly, but the gang takes turns until it loses its balance. The pack hunt like this all day long, but the one which gets there first eats the insect. Eventually, each archerfish gets its fill. To hunt alone would be too tiring and inefficient. But there is a way to get an even better strike rate. The archers have such accurate eyesight that they can pluck a fly from its perch. The archerfish lives in an environment that we can understand. The world of the monster you're about to see is decidedly alien. An eerie, darkened world of sea monsters. In the gloomy depths of the Sea of Cortez lurks the mighty Humboldt squid. These hunters can grow from the size of a sesame seed to over 2 meters in a year. That's like a human baby growing as big as a blue whale. To grow so fast to such monstrous proportions, they must eat constantly. But how do they find food in the black abyss? The answer is superior eyesight. When sunlight hits water, it splits into the colors of the rainbow. Red light gets absorbed quickly. Other colors travel further. And blue light penetrates the deepest of all. We can see these jellyfish at the surface because there's plenty of light. But as we drop down, the jellies vanish from view. At great depth, there's virtually no light. But the Humboldt squid's eyes are as big as tennis balls and contain a special filter to maximize the faintest glimmer. So whilst we see nothing, the Humboldt squid sees an abyss that is teeming with life. A recent discovery suggests the squid can hear too. Fine hairs along the head and arms detect disturbances in the water from fish up to 30 meters away. Acute eyesight and hearing make the squid an awesome hunter. Its nickname is the Red Devil, a creature rumored to pull sailors to their deaths. Next, we reveal an animal with an even greater appetite for destruction. Sharks are one of the most feared animals on Earth. Given the amount of press they get, you'd think we're familiar with their senses. So how did these sharks know that fish were hiding beneath these rocks? Let's take a closer look at these well-designed killers. Sharks were once thought of as swimming noses. Their acute sense of smell was at the expense of their other senses. The shark's nose is definitely one of its most impressive and prominent features. As it moves, water enters the nasal passage and flows over sensory cells. In the great white shark, these sensitive cells can detect a single drop of blood in an area the size of an Olympic swimming pool. The nostrils receive a scent at very slightly different times, so the shark can gauge its direction, effectively smelling in stereo. People wrongly assume that sharks have poor eyesight. In fact, many sharks have vision that's up to 10 times more sensitive to light than our own. What's more, a shark's eyes are on the side of the head, so they see a wide field of view. In hammerheads, this creates a weirdly distorted view of the world. But what really distinguishes a shark's senses from ours are two super senses we simply don't have. The first is that fish favorite, the lateral line. It runs down the side of the shark's body from nose to tail. As water flows over the skin, the lateral line detects microscopic disturbances and alerts the shark to possible victims. The lateral line is so precise that even a blindfolded shark can home in on prey. But the lateral line can't help if your victim isn't moving. So how do the sharks find fish hiding in coral? The answer, amazingly, is electricity. Although we can't feel it, every living creature sends out an electrical message each time a muscle moves. Sharks have evolved an organ in their snout which detects these tiny currents. They can sense them at up to half a meter. So for these fish, there's no place to hide. Life in the sea is tough, a case of eat or be eaten. Only those with the most finely tuned senses will survive. Our understanding of how animals experience the world is influenced by the limits of our own 5 senses. We can't see in ultraviolet, sense electricity, or taste through our toes. So some of raw nature's senses are destined to remain a mystery.